In this video, we're going to talk about actually coming up with an initial population given some information. So, after 20 minutes of growth, a population is measured and found to have 500 units. After 25 minutes of growth, it's 1,500. So, we want to find the initial size. To do so, the main thing we need is the growth factor. So, I'm going to use the form of the exponential y equals ab to the t. And a slick way we can do this is we can actually act as if 20 minutes is our initial to kind of speed things along. So I can say, well, it took to go from 500 to 1,500, it took 5 minutes. That's enough information for me to find my base. So I'm going to divide both sides by 500, and I get that 3 equals b to the 5th, or that b equals, we raise both sides to the 1/5, so 3 to the 1/5. There's the base of my exponential for this model. So I know it's going to have the form y equals a times 3 to the 1/5, or as I like to write it, t over 5. Now it's the a that we need. So what we're going to do is use some of our given information. We can either use that after 20 minutes it's 500 or 25 minutes it's 1,500. It's up to us. So I'm going to use the first piece. I know that the population is 500 when t is 20. So 20 over 5. So I get 500 equals a times 3 to the 4th, which is 81. So a is approximately 500 over 81, which is about, we'll round this off since we're talking about bacteria, it's right around 6 bacteria is our initial amount. Now the other thing we're asked to find is its doubling time. Now if you've seen some of the other videos, you know that we don't really need to know an initial amount to find the doubling time. We can go right from here. So let's do that off to the side here. I want to find when my initial value of a times 3 to the t over 5 is going to be equal to 2a. Okay, put that 3 in parentheses. So we can divide both sides by a, and those cancel. And, sorry, I'm running out of room here. What I'm going to have is that 2 equals 3 to the t over 5. So now we'll take log or natural log of both sides. So log of 2 equals log of 3 to the t over 5, which allows us to pull that exponent out front. So we have log of 2 equals t over 5 log of 3. Multiply both sides by 5, so that gets a 5 over there, and divide both sides by log of 3, and we get t exactly as 5 log of 2 over log of 3. Now a lot of times we'll want to give that as a number. So calculating it in our calculator, we get about 3.15, and now we did this whole problem in minutes, so it's about 3.15 minutes. Now let's think about that and why it makes sense. Well, sorry, I kind of messed up that part of the problem, but it tripled in only 5 minutes. Remember, it's exponential, so it grows a little slower at first and then faster and faster over time. So it's going to take a little bit over half to do half the work in the beginning, but then it goes quicker and quicker. So it makes sense that we had more towards 5 minutes than 0 minutes.